So being symmetry in 2 point, if we look at the x-axis, and if what we're trying to do is replacing y with negative, it would produce an equation that the graph is symmetric in respect to the x-axis. If we do that's going to be to the x, and it's going to respect this to the y-axis, and then the origin, which is the center, is when we're replacing the x with negative and y with negative, and then you see that it will be symmetric with respect to the origin. So let's kind of go through what that means. So to be symmetric to the x-axis, what we're asking to, if you have the original order pair of x comma y, you'll know if it's symmetric to the x-axis if the negative is changed. So if the y is positive, now it's negative, but the x remains the same, then we know that it's just symmetric to the x-axis. So the original one here was 4, 2. And if this graph goes through a point which is 4, negative 2, then we know that this equation or function is symmetric to the x-axis. So to be symmetric to the x-axis again, all we're doing is looking at the y's in the order pair and seeing if it flips as far as the sign change. Positive to negative, negative to positive, whatever the case may be. To be symmetric to the y-axis, we're looking at the x's now. So if the x's is once positive, now it's negative, or if it's negative, then it becomes positive, then we know that the function 2 squared minus 5 is going to be symmetric to the y-axis. So this one here, originally it was negative 3, 4, but this here is positive 3, 4. So because the x's change the sign, but and the y's still remain 4, then we know this equation is symmetry to the y-axis. The last one for the origin, if both of them change. So we have x and y and both of them flip the sign, then we know it's symmetry to the origin, which is the center here. So this equation here, 2x, x squared is equal to y squared plus 2. The negative here, negative 3, flips to a positive, and then the square root of 7 flips to a negative square root of 7. That means it's going to be symmetric to the origin. So once again, symmetric x-axis, we're going to flip the y's. For the symmetric to the y-axis, we're going to flip the x's. And then symmetric to the origin, we're going to flip from negative into negative x to negative y. So looking at this equation here, we're going to do the math. We're going to actually do the math and see whether this function is symmetric to the x-axis, the y-axis, or the origin itself. And once again, we're replacing for the x, we're replacing the y with a negative. For the x, we're replacing for the y, we're replacing the x with a negative, and then the origin, we have to do both. Once we do the math and we get back to the original equation, then we know we can put a check mark saying it's recessive. So let's give this one a try. For the x, if we want to see if it's going to respect it to the x, I took the y and made it a negative. Remember, take the y, make it a negative. How do we get rid of this negative in front? We divide everything by negative 1. So if I divide this by negative 1, we do like a sign becomes positive, this one becomes negative, this one becomes negative. Does this equation look like our original one? It doesn't. So that means that this one here is to the x-axis. Let's try the origin. I'm going to replace both this y and this negative with this y and this x with 2 negatives. I simplify. Try to get y to be positive. If I square this one, where I do get x squared, x times x gives us a positive x squared. However, if I get rid of this negative in front by dividing everything by negative 1, this sign gets changed to a negative, this sign gets changed to a negative. This one here, again, does not look like our original equation. So this one is not respected to the origin. If I do the y this time, the y-axis, I replace this negative, this x with this negative, because remember, for y, we got to replace the x with a negative. I square it. A negative x times a negative x gives you a positive x squared. This one looks exactly like the original equation. So that's why that for this particular equation, it's respected to the y-axis. So I want you to give it a try. I want you to test to see if it's respected to the x, the y, or the origin. So I want everybody to write this equation down. Go back to the other screen so you can kind of see the example of what we just talked about. So 4y and we're going to do and you're going to do perform each test to see if you get this back to its original equation. Equation in the chat box. So hopefully for this, once you did the, you realize it was respected to the y-axis. So this one is what we did. We tried it this way. It did not match up to our original equation, 4y equals 5x squared minus 6, and we did the origin too. So once we plug the negative in for x, for the x, and we squared it, we noticed we got the exact same equation of our original 4y equals to 5x squared minus 6, and that's why it's respected to the y-axis. So even in odd functions, so what we need to do is what this program was trying to tell us is we're going to figure out the fundamentals of figuring out if we can tell if a function is going to be even or it's going to be odd. By doing this, we have to test the even first. So the even part is what we're going to be testing always first, is try to do the even first. So all we need to do for the even function is take the x, for every x that we see, we're going to put a negative in front, and then simplify. The odd, if this doesn't work, then we're going to try the odd, where we're going to take the answer that we got from once we put the negative in, and then we're going to put a negative on the outside to see if we get the same answer. So let's do an example of this one. So here's my function, 5x to the 7th minus 6x to the 3rd minus 2x. And we're going to test for even first. So if you remember, we're going to take a negative and plug it in for x. So for this one here, we're going to make that a negative. For this x here, we're going to make that a negative. And then for this last x, we're going to make that a negative. So I took their and plugged a negative inside, and for every x that I see. If you did the math and said negative x raised to the 7th power, that's going to be, this whole part here will be a negative answer. If you did not know, if you raise anything, if you raise a negative to odd power, you're going to get the original problem back as far as a negative. If you raise it to an even power, then it flips and changes to a positive. So odd remains a negative. Even will go to a positive once we do the math on that part. So same thing for this one. If I have a negative and I raise it to an odd power, it remains a negative, and this negative tacked on with this negative makes it a positive. So this negative here that we've replaced it here, this negative and this negative will give us a positive 2 x for this one. So we look at this problem here. This one does not look like our original problem that we started with, because I have a positive, a negative, and a negative. This one's a negative, positive, positive. So since these don't match, we know that this function is not even. So what we're going to do is we're going to try the odd part now. So we take our original function, we put a negative out in front. So we're taking our, and see if we're going to be equal to what we matched here. So if we take a negative and put a negative out in front and distribute, this one becomes a negative, this one becomes a positive, and then this one becomes a positive also. This one here matches what we found for the negative once we did. Because these two match, we know this is going to be an odd function. The second part, part B, we're going to test again if it's going to be even first. If I put a negative in for every x, a negative here, and then I get the even part is for the even root for the even power, we know that this is going to become a positive. Two negatives again makes it positive, but this negative keeps it, and then we have this here. This looks exactly like our original equation. So we know this one's going to be a positive function. I'm sorry, even function. So this is just a background as far as the theory behind it. So when you're doing your book, the theory behind it, but this really the quick check for the shortcut is we're just going to look at the first power in every equation. So the degree of the first term. So if we look at the degree of the first term, it's a 7, which makes it a odd number. So we know that this answer is going to be, this function is going to be odd. Because the first power in here is even, this function is going to be even once we do the check. So that's just a little quick way of discovering if a function is going to be even or odd by just checking the first term, degree of the first term. So if you see it even, we know this function is going to be even. If you see it odd, it's going to be an odd function. So that's something you can do in MyMathPlus by just kind of looking at the first degree and determine whether but all this other negative stuff is just kind of like the background of how to get the odd or even function, or discovering it's going to be odd or even. So this will conclude section 2.4, and for this one here,